Question 5 was you have a group of 8 people and you're going to choose a committee of 4. We ask how many possibilities are there for the first person selected? Well, there are 8 choices. For the second person, there are 7. For the third, there are 6. And for the fourth, there are 5 remaining. So by the fundamental counting principle, we can answer these questions. How many choices for the first, second, third, fourth? Doesn't matter who's chosen for which position. The numbers are going to be 8, 7, 6, and 5. Because after choosing the first person, you're going to have 7 left. After having chosen the second, you'll have 6. I believe everybody understands that pretty well. Now, the total number of possible selections then, by the fundamental counting principle, would be 8 times 7 times 6 times 5, 1,680 ways to choose the 4 people. However, that's not really the number of possible committees that you get, because every possible group or every possible committee of 4 people could have been chosen in 24 different orders. Okay? Because if you have any group of 4, you have the same 4 people, you could have chosen the first, well, there are 4 choices, 4 possibilities for who got chosen first. And then there are 3 remaining possibilities for who got chosen second, 2 for who got chosen third, and of course that just leaves 1 choice for who got chosen fourth, but that makes 24 different ways of ordering the same 4 people. So the total number of committees is going to be what? It's going to be 1,680 divided by 24. Okay? Because you take the 1,680 ways that these people could have been chosen in order and divide by the 24 ways of ordering every possible committee of 3. Now we could write this out and we could divide it out, but I'm just going to leave it in this form right now to emphasize where the numbers come from. If we look up here, just expanding a little more, again, there are 24 ways to order 4 people, 4 choices for the first, etc. So there are this many possible orders. And now we're going to use this example to motivate our factorial notation. 4 with an exclamation point is read 4 factorial, and 4 factorial just means 4 times 3 times 2 times 1. So a number with an exclamation point means you take that number, multiply it by the next lower number, by the next lower number, etc., until you get down to 1. Okay, now I'm going to observe that this 8 times 7 times 6 times 5 that we get here can be written as 8 factorial divided by 4 factorial. Okay, why is that? Well, we just write out what 8 factorial means and what 4 factorial means. 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial means 4 times 3 times 2 times 1. So that 8 factorial divided by 4 factorial means this. And now we can group the 4 times 3 times 2 times 1 here and here. This is divided by this, it just gives us 1, and leaves us with 8 times 7 times 6 times 5, confirming what I said, that 8 times 7 times 6 times 5 is equal to 8 factorial divided by 4 factorial. And now, we've already calculated this. This is 1,680, if we wish. The 8 times 7 times 6 times 5 gives us 1,680. So the number of committees here, 1,680 divided by 24. 1,680 is 8 factorial over 4 factorial, and 24 is 4 factorial. And I can write that out here just to be sure we understand that. Okay, so this 1,680 divided by 24 is 8 factorial divided by 4 factorial. That's the 1,680 divided by 24 That's divided by 4 factorial. So that the number of combinations here is 8 factorial divided by 4 factorial, and that divided by 4 factorial. Now, I'm going to extend this discussion a little bit and a couple of other things in a subsequent video.